250. And the Swan 250, of course, is a 6-meter only version of, I guess, something else that they made. Anyway, I only had a technician license, but they had a 6-meter antenna up on top of a telephone pole at the club station. And I'll tell you, I fired that thing up, and the E-layer opened up, and man, I was just cooking. I was talking to people all over the United States with that rig.
Oh, I bet so, yeah.
Yeah, I really like the looks and layout of, well, of both of those models, actually. And I guess the thing that impressed me was the vernier dial that they had built into the main tuning dial. You could QSY fast by using the outer ring and then slow it down and tune them in with the inner one. It was just a nice little radio to operate. That was the thing that got me.
Oh yeah, they were neat. They were neat, definitely. I have a couple Cygnets, Swan 260s. They got one sweep tube, and they're a lot of fun, man. And they don't even have AGC or AVC. 100% you have to control it. They don't even have a volume control. Only RF gain.
Yeah, they were pretty bare bones back in the day, weren't they? I remember when those things first came out, the Swan monobanders, oh gosh, what was that, late 60s, mid to late 60s, and everybody was talking about it, and they just couldn't believe that you could get a radio with that capability in a package like that, and at a price like that. I mean, these guys were, buying these 100-watt Swan monobanders, and of course that was at the peak of the sunspot cycle, so they'd take those things home, load them up into a random wire or something, and work the world with them. And they just couldn't believe that a complete transceiver could be made that cheaply.
Yeah, that 260 Cygnet's fun. I've worked the world with it. I've put the thing into the beam and worked all over the place. I mean, I remember days sitting there with it, just me, the radio, the mic, and working Japan and all over the place. And it was fairly stable, really. I mean, it wasn't bad. It certainly wasn't rock solid, but it would sit there on 20 meters, no problem. I'd tune people in, make the contact, and tune around, find somebody else, and no S meter, no AGC, no AVC. So you had to have your hand on the RF gain, no volume control. But it did have a Magic Eye tuning tube. So when you flipped it into tune, the little tube lit up, and you would tune the plate and the load and the pre-selector for maximum closure. It was kind of cool.
Yeah, I guess it was a real innovation in the day. Had a transistor power supply if you ran at Mobile too, as I remember, and that was a big eye opener as well.
Yeah, in the ad they show what I think is in the background. Well, they're on the tarmac. I think it's what was the airliner of the day? The Strato Cruiser, Strato something?
Yeah, Strato Cruiser, big old Boeing with a bulbous nose on it.
Yep. There's a Strato Cruiser in the background, and there's a man resembling Cary Grant. Okay, he's in the suit. He's got the haircut. He's holding a suitcase, and he's got a wife standing next to him in the ad. She's in a dress, a full dress, and a hat, and she's holding the Swan Signet 260 by the handle, and they're heading out to get on the Strato Cruiser.
Yeah, good image, I've got to say.
You can take your ham radio with you. Even she can carry it, it said.
Yeah, that was cool. And, that was a thing, Curtis LeMay and Art Collins flew around the world in something like that. The military version was a KC-97. And that's when Art Collins convinced LeMay that single sideband was the way to go.
Yeah, that's right. I remember that story. Yeah, my YouTube was running the other day while I was working, and it actually came on with a program. I watch aviation stuff, and it had the Strato Cruiser on there, and it was talking about, the experience, not so much the plane, but the experience of what you would eat, what you would drink. People were smoking, they went through the whole thing of the flight attendants. The flight attendants, they had to be from the age of 20 to 25. That's it. After 25, they wanted another young one.
Yeah, I know. They were just unbelievably ageist, sexist, misogynistic, everything like that. You know that that airplane that you were looking at with that was actually a Boeing 377. And that was actually a reworked B-29. They redid the fuselage, but the wings and tail were off of a B-29.
Wow, I didn't know that. So it was lumbering along, like if you put
a number of their airplanes over the years, starting with the 30s, they built I guess a light bomber for what would be called a medium bomber in that day, and converted it into a two-engine transport. And then immediately after World War II, they fielded an airliner that was derived from or basically used a lot of the same tooling that B-17s did. It was a tail dragger, if you can imagine that, a four-engine tail dragger transport aircraft, and then that 320 and then 377 was built, I think initially with B-29 components, and then it may have been upgraded to a B-50. Boeing made an improved version of the B-29 called the B-50, and it became instantly obsolete with jet bombers. But and all of them got converted into tanker aircraft. And I had a whole couple of squadrons of KB-50 tanker squad guys at Biggs Air Force Base, so we saw a lot of those things coming over.
Wow, that's really cool. Yeah, they would come around and give you a hot towel. Men got a bourbon. Women got, some kind of cocktail or wine. And you lit up a cigarette, you relaxed and sat back, and they served you airline chicken, and I don't know. It was a funny documentary, really.
Yeah, the first time I flew in a jet aircraft, or jet transport, flying from El Paso to Dallas, And just as they were serving everybody shrimp cocktails, why the thing hit a bunch of clear air turbulence, and boy, we were just, it was like being on a roller coaster or an out of control elevator or whatever you want to call it. So I was just sitting there with, having this shrimp cocktail trying to float out of my hand. I turned to the people that were sitting next to me and I said, I didn't realize that this was one of the challenges of the aerospace page.
Yeah, well, I imagine. I'm trying to remember, my parents used to put me on a Braniff flight from San Diego to Newark. And that would have been about 84 or 85. Maybe 83, 84, 85. Every year for the summer, they put me on a flight by myself, handed me off to the flight attendant, and then my grandparents would pick me up on the other side there in Newark. So what plane would that have been? A 727?
It wasn't a 747, was it?
Oh, no. No, it was just an intercontinental Braniff flight. So I don't think they didn't have 737s then. So, I mean, just off the top of my head, it would have been a 707 or 727, right? Or maybe, you know what it probably was? It was a TriStar.
Yeah, McDonnell Douglas DC-10.
Well, the TriStar, yeah, with the 3 motors.
Yeah, that was actually a wide-bodied thing. Well, they made 2. Lockheed made one as well. The 1011. I guess that was what I guess that was the Lockheed's designation for that, wasn't it? TriStar.
I think that was the L-1011.
Yeah, L-1011, I believe.
Well, the question is, how many aisles did it have? If it had 2 aisles side by side with seating in the middle, it was a wide body.
I don't remember, but I'm looking it up. But I can remember sitting there, which felt like an eternity because we're flying across the continental U.S. as a child, and everybody around me, including the people next to me, smoking, chain smoking the whole way and putting cigarettes out right in the ashtrays.
Yeah, those were the good old days.
Yeah, when they had ashtrays.
Yes, and when the no smoking sign would come on and go off with a loud ding sound, and the flight attendant would come off and tell you that smoking was now permitted, and the whole 9 yards. And also, we're going to be serving hard cocktails all up and down the aisle.
Okay, it says here it would have been the BAC 111 Series 200.
Oh, really? Okay. Yeah, that actually was a rather small aircraft, actually.
I don't think that's right. Because I don't think it was a full-size plane. I don't know. I'm confused here. I'm looking at it. Before that, they flew 707s, but they claim that well, hold on a second. It's not in order. Oh, okay. I had to scroll down here. It would have been the 727, Jim. Yeah. Yeah, they flew 747s and 727s, but in intercontinental they were 727 100s and 200s.
Yeah, well, I'll tell you, I thought that was, and that's right, that was a tri-motor aircraft too, wasn't it? And anyway, when they first started flying those things with their clean wings and, whatnot, I thought that was the most beautiful airliner I'd ever seen.
Yep, it does. It was tri-motor. And they had the motors, let's see here. Were all three motors in the back, or wait a minute, no. I think the 727 had, no, they were all in the back, right? Yeah, that posed a real safety concern, and they got away from that. What was it? My mind's going blank. If they lost power for whatever reason, it was almost impossible to control the thing because the thrust was behind the wings.
Well, I'll tell you, it took, I think we had a couple of them when they started first flying those things that the pilots of that time were not quite familiar with the dynamics of the aircraft, and I remember one in Salt Lake City came in and hit the ground hard and dug two furrows right through the runway and into the dirt with the landing gear, and then belly landed on down the. I think that was a really bad crash. I think people died in that.
Yeah, I'm trying to remember what they call it. There was a term for it, but they all kind of decided that it was a bad idea to have the motors behind the wings. Oh, you know what it was? It was something to do with the tail rudder. The tail rudder, let's see, if you had the thing at full throttle, the tail rudder did essentially nothing because it had a motor in the middle and two flanking it, and so the controls would basically go numb. And so if you were in some kind of an emergency situation where you had to have the power cranked up, well, you couldn't steer the damn thing.
Yeah, I didn't hear about that one. Who was the other station there? Was that you, David? Were you back?
No, this is Chuck, N2THD.
Oh, good evening, Chuck. Jim out here in Glendale, K7JEB.
Yeah, hey, Chuck.
Hey, Clark.
Yeah, that's what it was, though. They actually had a term for this condition. But in that YouTube program that I kind of halfway watched, they talked about this, and I mean that kind of makes sense, right? If you've got those tri-motors cranked up, well, the rudder that's not going to be effective because the rudder is out there in the jet wash, and so the pilots would get confused because they'd be telling the thing, hey, we need to turn over here, but it wouldn't turn over there. The only way to do that would be to reduce the power, and then the rudder would have effect, and then they had to put the power back on. And so it became a very, very confusing thing. And of course, putting the motors down under the wings completely cured that.
Yeah, that's interesting. I wonder if the DC-9s had that same problem.
I think all of them that had the motors back there did. I don't think it was even the tri-motor ones. If they had the motors flanking the rear fuselage across the rudder, I think it at high power in certain situations the rudder was essentially useless. That was the big concern. You know, and I think that's why they got away from that. They moved them forward to the wings, and the rest is history. They had full control of that rudder at all times.
Yeah, that's something, you know, lessons won the hard way, I guess. But that's interesting that would happen. But yeah, you know, there for a while there, it seemed like I remember the French had an aircraft called the Caravelle, and I can't remember whether it had 2 inches back there or 4. I seem to remember having 4, it having 4 back there, but I may be thinking about another airliner that was also made in France.
Which one was the one that was extremely underpowered? Was that the MD-11? I think so. MD-11.
Yeah, I don't know. But I'll tell you though, that hardly saw the for passenger service. That thing hardly saw the light of day.
Boy, they love to put big bleeder resistors on high voltage power supplies back in the 50s and 60s, didn't they?
Well, that was part of giving them good regulation.
I'm not really sure if that's true. You know, I don't know. I'd have to be challenged on that because, you know, unless it's an extreme situation, okay, where something isn't designed correctly, when you key the transmitter, well, you've got 200 milliamps of load on it because that's what the idling current here is. So, you know, the tubes are the load. So, you know, I mean, unless you're talking about like 400 or 500 volts of swing or something, I really don't know that that's correct. But this thing here, you wouldn't even believe the heat that it belches out of the power supply at idle. It's just unreal. I mean, it's got to be hundreds and hundreds of lots of heat.
Hey Clark, I think those bleed resistors are supposed to help with the startup surge.
No, because even this thing has a 2-step. It makes it start out on low, and then you have to physically push a high button to go to high, which the step starts it. But I don't know. This thing is belching heat out, and that's the way it is. But I really question the need for that. You know, like, I don't know, radios in the past, Jim, like my Invader 2000, by the way. That thing I calculated had 500 watts of bleeder heat coming out of it. And I went in there and cut it in half, rewired it had big 200 watt resistors stacked on some kind of a heat resistant bracket. I don't know what it was made out of, like fiberglass or some kind of mica. And anyways, I went in there and rewired it to exactly half of that. Well, I mean, there was no change except heat wasn't boiling out of it.
Well, as long as the smoke doesn't leak out.
Yeah, our friend Bill VZP does that's one of the mods that he puts in these linear amplifiers. He takes out the low-value bleeder resistors and puts in some fairly high ones. And the result is that if you turn your amplifier off, it may still be charged up a little bit, 10 minutes later.
I don't know if it's 10 minutes, but yeah. I have a homebrew amplifier, and it doesn't have much bleeder. I would think that it goes from 5,000 volts, if I have the Variac cranked up there, but 5,000 volts to 0, and I would say 2 minutes, 2 to 3 minutes. It's not lethal past a minute. But you really would want to give it 2 to 3 minutes before it really was down. The thing is it's impossible to physically get into the cabinet and kill yourself within that time frame. There's too many screws. You'd have to pull the cabinet around and pull all the screws out to get the whole back panel off the thing. So, you know, it's deemed safe. So that's not a problem. But, man, I tell you, back in this era, boy, they wanted that thing loaded down.
Well, that thing also, that runs a pair of tetrodes, right?
Yeah, it's got a pair of 8122s. They're 400-watt tetrodes.
Yeah, where do they get the screen voltage for those things? I've forgotten.
That's a good damn question. I have no clue. It comes from the power supply in a separate, there's a B plus and a screen wire, and it's incredibly dangerous. So picture this. You know the regular red high voltage wire that you would definitely not reach down there right now and grab. I don't know, maybe it's 10 kV, like neon sign wire. It's got 2 of those coming out of a rubber drum, okay? And they're tied together about every 4 inches with braid, like little, like somebody actually braided the string. That goes to a connector with 3 prongs on it, and that plugs into the back of the radio. So, like, I'm very confident, like, if I reach my hand back there and grab that, I might be dead.
Yeah, that's it. Yeah, but that's a good point. I ought to pull up the schematic of the power supply of that thing and have a look-see and see where they get their screen voltage. I think that, well, anyway, it's, I think that's why they did that, or trying to stabilize the high voltage a little bit more to, I guess, keep it linear or something.
Yeah, there's no regulators in here. I'd have to pull it up here. I think you're probably right. That's what they did. It's going to end up being some droppers, some kind of a dropping network that supplies the screen, which can be successful. The way that we do it now, though, on big tetrode amplifiers, just in case you're curious, you've got the B plus running. That's a separate supply. Then we'll have a 1,000, 1,500, or 2,000 volt transformer, or whatever screen voltage is needed on a big tetrode. It'll be a separate transformer. It'll be a cap input, a bridge, cap input supply. And then there's a high voltage relay on the output of that. And that thing's going to be looking at a real heavy load, like 10K. So you have to calculate this to where that screen transformer is really under a heavy load, but it's not harming it. But that's the only way you can get stability there. So, like, if it's a half an amp, you know, we're going to want 250 to 300 milliamps on it at all times. And then the high voltage, the cathode is grounded permanently. And then the high voltage from the screen goes through a high voltage relay to the tube, and it's screen keyed. And and it's absolutely beautiful. You key the thing, you don't hear a click, and all of a sudden you just got idling current.
Yeah, that's cool. That's a nice way to interlock it, I guess. Wow. Yeah, I'll have to take a look at that thing. Get to know your SR2000 a little bit better than just how to wire up the TR I guess that's called a Vox relay, right? The Vox keying relay. On that, take my narrow focus off of that and get to know that radio a little bit better.
Yeah, it's kind of funny. I mean, 2 weeks in, I kept saying, there's got to be an easy way to do this. So there it was.
Yeah, there was. And, the thing is that, quite frankly, you were halfway there with your 680K resistor.
Yeah, I know, because I went in there and corrected it with the RIT, and I saw, hey, the VCO voltage changes, and so now I need to put an offset there. And so that's when I went down that road, and I thought, well, how in the hell am I going to put that in there? But the answer was right in front of me. But you got lucky with the 10K.
Yeah, it was, although, if I think about it, sometimes you do a calculation in the back of your head that you're not really aware of, because what we needed was a 100 to 1 step-down ratio between the voltage that was on there and how much we wanted it to shift, and there it was right in front of us.
Well, more than a week ago, I had pulled the 8-pin wire, and I stuck that through the ICO resistor box in series. And I had turned every single knob on the thing looking for a frequency change. And I said, that's weird, it's not working. It has to go to ground. And then I thought, well, damn, this isn't going to work because a series resistor isn't going to do it. I needed to go to ground, and that's where I got stuck. The answer actually was the 1 meg to ground. When you said if the 1 meg to ground isn't there, this won't work, and that's when the light bulb went off for me.
Yeah, and my thinking, the context that I was thinking of is that you needed that 1 meg ohm to ground to make draw enough current through the diode to make it work. It never occurred to me that we could have gotten away with a resistor. A diode actually, if we had a diode with a forward voltage drop of, 0.05 volts, or 0.06 volts, or whatever we needed, that would have been the optimum solution. But just pulling through the selection of Schottky diodes, trying to find one, and I don't think you would actually. I think all of them are going to have a certain amount of that forward bias, although it's surprising how, to my mind, how much that does vary. I was just looking at Schottky diodes, and some of those things have a very small forward voltage drop. But it always is in the neighborhood of, 0.1 to 0.5 volts, or 0.3 volts or something like that. It never really got down below that.
Yeah, it would be interesting to find out what he did 10 years ago, but I suspect he he somehow leveraged a resistor and a diode, only because I've studied the photographs, and he's got a diode there, and it's a black and white photo, but I have a feeling it was a blue banded diode. The reason why is in another picture there was a regular silicon diode, or like a glass diode, and which would have had an orange band, but it didn't have that same shade. And so I thought, man, that looks like a blue banded diode across there. But, I don't know. You could have 10 different engineers look at this and come up with 10 different solutions, I guess.
Yeah. Well, anyway, my ultimate solution is take that VFO out of there and put in a DDS VFO and some kind of shaft encoder for the VFO dial, and there you go. You know exactly what you're producing out of that VFO. Unfortunately, it only would go up and down in 100 hertz steps or something.
You don't even have to do that. All the VFO is on that back accessory jack. I could go get one of my DDS VFOs and probably within about 15 minutes wire up an octal socket to where it would work right on that back socket. And I mean, you would never have to deal with any drift. The thing would just sit here rock solid all night.
Hey, can I break in here for a second if you can hear me?
Yeah.
This is yaesu. I was wondering where you guys are at. I'm just experimenting around with an antenna connection here.
Yeah, well, I'm K7JEB, and I'm in Glendale, Arizona, southern end of Glendale, Arizona, 67th Avenue and Camelback Road, over.
Okay, well, that's pretty precise. Alrighty, well, you're putting out a tremendous signal. I'm in western Washington here in the lower part of the Puget Sound, and I've got about 300 feet of wire up around close to 100 feet in the air, stretched between some trees that's off center fed, through some ladder line with an antenna coupler mounted outdoors. And I'm driving it with a little Hermes Light 2, eventually feeding an old Heat Kit SP201 amplifier. So it's quite a menagerie on my end. Over.
Well, I think you're doing very nicely with that. You're about 10 over S9 here in the Phoenix area, and interesting note that I think that's the first Hermes light I've heard on the air. We've got a local guy here putting one together, and I think maybe a couple other people in the valley, but first one I've actually talked to.
Oh, okay. Well, I've been running into more and more people with them. Once I heard the receiver, I was out of ham radio for about 20 years. I was into it clear back in the 1960s, and I worked in the two-way communications business my whole life. And I got a Hermes because I read a lot of reviews about people ranting and raving about it, and they seemed like fairly reputable people, and the price of the thing seemed awfully low for something I could take it. It was low enough to where I could risk purchasing the thing and having it just be another SDR receiver like a bunch of other ones that I had, like they fit on a little dongle. I got the thing and hooked it up to an antenna, and once I listened to it, there was no possible way I could go back to my ICOM 706 Mark II that I was using.
Okay, well, very good. Yeah, that was my take on the whole SDR thing when when ICOM came out with the IC7300, I said, okay, there you go. That's SDR is going to make ham radio transceivers super cheap and super high performance, and it looks like, in fits and starts is doing just that.
Well, a tremendous amount depends on the software driving the thing. It's much more complex than I first thought it was. It involves a huge integral part of the whole operation is a FPGA chip, a field programmable array chip, and the way that they're using it is it's just incredible. There's a tremendous amount of stuff that's going on inside the chip, and if the software isn't written just right, it can create a lot of issues, and I think there were and possibly still are issues with some of the SDR, the traditional, especially the ones that are made by people like ICOM and Kenwood and yaesu, where once a product hits the market, they're really not prone to wanting to dump a whole bunch more money into upgrading the software later on. Whereas with these open source projects, you're on easy street because they're being upgraded all the time.
Well, yeah, that's true, and you're absolutely right. Yeah, I can remember back in the day when the Flex Radio first came out with their 1000 model, and that relied almost entirely on the host computer to do all of the SDR or all of the signal processing, all of the DSP calculations, and all the radio was a bunch of fairly high performance A to D and D to A converters and a linear amplifier, and that first Flex 1000, that was a twitchy thing, and as they started incorporating dedicated FPGA processors to the first stages that have to be done very fast and with a lot of power behind them. So basically inside that FPGA, you've got hardwired resampling filters and hardwired FFTs and whatnot that can be selective, switched in and executed and switched back out again. And that's I saw when they started getting big enough and fast enough FPGAs in there, I really thought that we were going to see some spectacular radio equipment with some spectacular performance, and yeah, that's coming to pass.
Oh, hopefully it'll get better too. These chips that they're using are pretty expensive considering the average cost of a product that somebody buys. There are very few chips that go above $20 or $30, and there are with I guess the FPGA chips for the real high-end ones, they want a few dollars. Anyway, it's always advancing, and I've had a lot of fun with this little Hermes radio. It's very impressive, and I guess they're coming I've seen a 14-bit version now being advertised. I haven't heard any reviews or anything, and I think it's kind of sketchy because it's being sold directly out of China with no other backing, so I'm kind of skeptical about it. Anyway, we'll see what happens here. So right now my setup is just kind of jury-rigged. I've got a solid-state amplifier that I got together at one point in time, and I managed to blow it up, and I'm going for the second try, having learned quite a bit, and I'm going to go into it being a lot more cautious this time. I pushed it hard, and I knew that there was a big risk, considering that I didn't have any rural protection hooked up to it. So that's my next project, is get the amplifier situation going. Alrighty, well, I'm going to bail and just listen. I didn't mean to interrupt you. I heard you out there talking. I got an electrical engineering degree many years ago. As I recall, they were just scratching the surface on digital signal processing. That was kind of one of the brand new things, and it was basically it was down in the audio range. Nobody had even dreamed about a digital signal processor that could directly process levels at RF frequencies. Anyway, it's all good stuff. 87IS, I'm out here sandbagging.
Okay, AA7IS K7JEB. I sure can relate to that. Again, I did my PSWE at El Paso, the University of Texas at El Paso. So we were doing good to get away from slide rules, okay? And my baptism of fire in DSP came when I went to work for Goodyear Aerospace out here in Litchfield Park that specialized in hardwired radar signal processing for synthetic aperture radar. And that was my baptism of fire into DSP algorithms and fast Fourier transforms, and I can still kind of remember some of the math there, but the field itself has moved much farther away from looking back at the architectures that we had then and what's being done now, and much more of it being software defined and software implemented, and that being done on general purpose processors or special purpose processors or sub-processors like FPGAs. So, yeah, I was in it for a while, and then kind of got shunted over to a whole other field like that. But it's still a very interesting development. It was really fun to be participating in it when I did. Okay. By the way, what's the name there? My name is Jim, and again, we're located out here in the western part of Phoenix. Go ahead.
I'm going to jump out of here, Jim. You get 73s. W7WRX. I got to be at work in the morning early. Thanks again.
Okay, I hope I didn't chase them off. This is 87IS. My name is Aaron with Chile Alpha Romeo Oscar November.
Okay, Aaron. Are you a native from up there, by the way?
I've lived off and on all over the place. I was a Navy brat, so I was born in San Diego, California, but my father's family and mother's family are all from Washington State, and the property that I'm living on right now has been in our family since 1920, so I'm third generation here where I'm at in this particular spot that I'm on right now.
Oh, okay, very good. And I spent about 6 years up there, 7 years actually, working for Boeing in Seattle. So, what little town are you in?
I'm in a little town called Lake Bay, which is right near a park called Penrose Point State Park. It's on a little peninsula of land that sticks down into the southern part of the Puget Sound. So I'm basically surrounded on three sides by salt water. The property that I'm on a little ridge that stands above everything on either. The property slopes away on both sides from where my antenna is, so that helps a lot. And I think it's got pretty good ground conductivity. Anyway, I don't know where I was going with that. I worked a lot up in Seattle. I worked for a couple of different companies. When I was a youngster, I worked for an outfit called, my first job out of high school was Eastkid Electronics up in Seattle, Washington. Back when Eastkid Electronics was by the big gas company that had the big blue flame. And then I went from there. Eventually, I ended up over at ICOM for a while, and then I had little stints with all sorts of different places after that throughout my career. Over.
Well, very good. That's quite a thing. I kind of went through aerospace gypsy phase of my life back then, bouncing between aerospace contracts and boom and bust kind of things. Last person in Seattle, please turn out the lights or something like that. But the thing that I guess I finally settled down here in the Phoenix area and set up diversity in the electronics business to keep me busy, kind of like you, floating around and working for various people. Interesting that you worked for ICOM for a while. Anyway, the deal with Clark W7WRX there is that he's been working on a really big problem at work that he's having to deal with, and it's not over yet. So you didn't run him off. He just got tired. I guess we kind of got carried away with the conversation here too, Aaron. Let me go ahead and send it back to you and let you go ahead and wander off if you want to. Actually, I think I probably need to wrap it up here as well. AA7IS from K7JEB.
Well, before you go, weren't you guys talking about diodes and on resistance and various different types of diodes?
Yeah, we were trying to use the forward voltage